All right, Chapter 6, Section 2 on flooding. The chapter itself is on floods and flooding, but the whole first section we had gotten done talking about the mechanics and structure of rivers. And so flooding itself is really a natural process. In fact, a lot of these disasters, we call them natural disasters for a reason. But it's flooding is very, very common. It's very like I said, it's a very natural thing, so it's not like it's some out of the ordinary thing. But when people get in the way, that's when we run into difficulties. So, what causes flooding to take place? Well, a couple of different things. First of all, too much precipitation in the drainage basin. Right? Drainage basin, remember, or the watershed, you can call it, is the whole area that a river collects water from. And if there's too much precipitation in that drainage basin, that's going to contribute to flooding. It's going to overflow the channel right there. These last three right here are kind of all related to each other, and they all just speak to how fast the water gets from the land to the river channel. If the precipitation can't soak into the earth very fast, well, then you're going to have water getting into the river channel faster than it should. This is kind of the same thing right here. I mean, how fast it moves over the land to get into the river channel. And this last one also speaks to that. If there's too much moisture in the soil, then that means the water can't seep in, and therefore it's going to run over the land further and probably into the river channel. So all these things together contribute to actual flooding itself. All right, so right here is a picture of, there we are. As a picture of an area that it's perfectly natural for flood to take place. You can see the two pictures are basically the same picture. Right here is the river channel, and the flat area on either side of it are the floodplain. And so when too much water gets into that river channel, I mean, you can see right here the level of that water is just about at the rim of that river. Then it's going to spill out over into over that whole floodplain right there. So snowmelt is one of the things that can contribute to that as well. A lot of water melting, snow melting all at once creates a lot of water. All right, so what is it about floods, or what determines, how do we measure floods? Well, the flood discharge is really what we call the amount of water. You might say the maximum amount of water that the river can take before it starts to flood. So when it's at various stages, or when it's at flood stage, that means it's right at, you might say the water's right at the rim, right at the edge, and can't hold any more before it starts to spill out over onto the side. So flood stage is where you're going to really start to have property damage because of water spilling out onto the floodplains. There's a graphic that can be made called a hydrograph that shows how over a period of time the a river's discharge changes. You might say they'll have less discharge in the dry season and greater discharge in the rainy season. But that is just sort of a graphic that illustrates how that can change over time. So depending on where you're in, you might have different kinds of flooding take place. If you're in Zone 1, and recall Zone 1 is where the land is very steep and water is going to rush off very, very fast. This is where we see what are called flash floods. And by flash, when you think of flash, you mean of something happening fast. This is exactly what happens. Floods just pop up very, very quickly. Many times because of intense rainfall over a short period of time. But it's all this water all of a sudden going into the river channel that just can't handle it. Many times it's arid or dry environments that have flash floods. And you would think, man, if the environment is dry, wouldn't it soak up the water? Well, the problem with arid environments is that it causes the ground to be very, very packed down and hard, and the water can't soak into the ground very well. So it rushes right off and goes into the river channel. And kind of ironically, people that are in cars are more likely to die because many people underestimate the power of flash floods and get caught in their cars and aren't able to escape. So Colorado is a good example of a state that oftentimes gets flash floods. It's got the Rocky Mountains, so it's got a very steep hillsides or mountainsides, so water rushes off quickly, but also is somewhat arid as well, and so the water can't seep into the soil, but rushes off, and so we have images like this right here that are common in Colorado as a result of flash flooding. Zone 2, as you might recall, this is the zone where water is transported overland, point A to point B. All right, and Zone 2 is where we have the floodplains and where we have rivers meandering back and forth. All right, that whole area is susceptible to flooding, and so that large area is going to be covered with water, even if the water rises just barely above flood stage. This is the state of Ohio, right here. Actually, it may not be the state of Ohio. It's the Ohio River, but if you know anything about Ohio, it's somewhat flat, and not too many mountains there. Maybe a couple of hills, but it's mostly flat, and so it means that there's going to be a lot of Ohio that is flooded because the water is able to move out in all directions. The Mississippi River, you probably know, is very susceptible to flooding, and time after time, we have major flooding taking place on the Mississippi River. The Mississippi River is, you might say, Zone 2, because it's where water is being transported from where it originates to where it ends up in the ocean. The thing we've learned about from the Mississippi River is that various different flood control structures aren't necessarily the most helpful. A levee. Right? A levee is basically the same thing as a flood wall, but it's a way that you can artificially make the river channel deeper and therefore hold more water. Well, they only are able to hold so much until they overflow, and then you've got a bigger problem. Here's what I mean. So this whole area right here, all that is susceptible to flooding. And it just has to be something that you live with. But the good news is that whole area is farmable, and you have vegetation that can grow there as well. When you put a levee up, and as you can see, a levee is like an artificial wall that contains the water. It makes less area farmable, and the other side effect is that even though maybe your actual farmhouse won't get flooded with floodwaters, the problem is that it sends a lot more water downstream, and so people downstream who may not have levees they've got a problem they have to deal with. So levees and flood walls can sometimes create more trouble than they're worth. The city of St. Louis, with the Mississippi River flowing through it, has several levees. You can see right here on the left. These red lines right here indicate levees or walls designed to hold back water. But as you can see, in 1993, doesn't necessarily help. All these pink areas right here are areas that were heavily flooded in 1993, and so these levees really didn't do much help right there. And in many cases, they create more problems for people. As far as Zone 3 goes, remember Zone 3 is where all the sediment gets dropped off into either the form of a delta or an alluvial fan. What happens is that these piles of sediment, the water can change direction or change the path through these piles of sediment, and therefore the channel during one flood, it may be different in a secondary flood right here. So it doesn't really give you an idea of where the water is going to flow in a certain flood. A good example of that is the Ventura River, and I believe that's in California. But the Ventura River had an RV park, like a recreational vehicle park, campers and stuff that was built there, and they found that. Well, they hadn't really studied the river long enough to realize how much it floods and how much it changes direction over time because of the sediment that was deposited there in Zone 3. And so this park floods multiple times, even despite them trying to put up levees and flood walls and stuff. They did develop a warning system, but it didn't help the fact that the park itself actually flooded more often than they wanted it to. Here it is right here, once again, underwater. And you have this river kind of going in two ways around it. And there's, of course, this super highway right here with bridges. And they try to put up levees. You see this levee right there, that little wall, and there's others around it that try to contain the water. But the problem is, just over time, this is, like I said, this is flowing out to the river right here. So you're going to have an alluvial fan, or you're going to have a delta right here. These channels change direction all the time. So you put levees in place, and then the river changes direction again. And then you put other levees in place and other structures right here, and the river changes direction again. So this RV park just seems to be destined to be flooded all the time because it's just in that spot right there, and there really isn't a whole lot that you can do about it. So that's a Zone 3 flood that takes place. You also have mega floods. That is just floods that take place over maybe Zone 1, N2, N3. That is really just a result of way too much water being dropped over a long period of time. This term atmospheric rivers right here, you may be aware of a thing called the jet stream, which people call a river of air. But when we say atmospheric river, we actually mean an area in the atmosphere that is likely to bring water to us. And as our last slide right here, I'll show you what I mean. This right here is kind of a graphic of an atmospheric river across the Pacific Ocean. And if you're under any one of these areas right here that is red or orange, all right, what that means is that you're under an area that brings a lot of water vapor to your area. A lot of water vapor means a lot of rain, and so areas that are underneath where you might have an atmospheric river are susceptible to flooding or even possibly mega flooding over longer periods of time. So that's section 2 on flooding itself. The next sections we're going to look at how we respond to flooding and the human impact that floods have. But for now, that's section 2. Thanks for watching, and I'll see you on the next one.